Greetings! In this tutorial, I will show you a simple, reproducible workflow in 3D Slicer to segment enamel, dentine, and the pulp cavity, as well as computing their volumes. Alright, so I have my dataset loaded here. It is an image stack in BMP format from a micro CT scan of a tooth. And I have already set the resolution, which is 15.9 microns, and then took care of all the necessary preparation steps. So we are ready to start. If you would like to see exactly how to load image stacks into 3D Slicer and prepare your dataset for analysis, feel free to check out my other video. Now, if we take a look at the yellow or sagittal view, you can clearly see the different parts. The enamel appears as a bright gray because it has higher X-ray absorption. The dentine shows up as a darker gray, and the pulp cavity appears as black. So let's switch over to the segment editor module and start with the segmentation. I'll create the first segment by clicking Add. Then I will double click the name to rename it to Enamel and pick a color for it and click Select. The enamel has very good contrast compared to the rest of the scan, which makes the segmentation easy. Let me hold down Shift and hover the mouse over to the enamel so all three views center on it. Here in the axial view, we can also see the enamel very clearly. I can simply use the threshold tool to segment this part. Once I adjust the threshold range, something like this, so the entire enamel is highlighted, I'll click Apply, and that becomes our first segmentation. Let's quickly check the result in 3D by clicking Show 3D. It looks a bit small at first. Let me first center it and then zoom in. It looks good, but the surface over here, for example, is a little rough, so it could get some smoothing. Here is the smoothing tool. When using this tool, it's important to pay attention to the kernel size. Since my scan resolution is 15.9 microns, the kernel size of 3 millimeters would actually correspond to about 189 pixels, which is far too large. Let me first change the smoothing method to Gaussian, then reduce the standard deviation to roughly 2 or 3 pixels, something like 0.03 millimeters, and click Apply. There we go. The surface looks nicer and smoother, and those sharp edges are gone. Next, I want to remove these small floating parts. Because they are completely disconnected, the Islands tool is perfect for this. I'll choose Keep Selected Island. Then in one of the 2D views, for example here or here, I will click on the main enamel region that I want to keep. And now all the small floating pieces are gone, leaving only the main segment. Let's set the segment status to completed by clicking on this icon and move on to the dentine, which we can see it here in darker gray. Just for a better visualization, let me first make the enamel segment invisible by clicking this eye icon next to it and then create a new segment. Name it Dentine and give it a color. I can use thresholding again. Adjusting the range like this gives a nice coverage of the dentine. You can see it is nicely selected, although there are some extra regions up here get included because of the partial volume effect. We will clean those up in the next step. Before applying, I'll change the editable area to outside all segments. This prevents any accidental or unwanted changes to the enamel segment or the segment that I have already created and keeps them intact. If during thresholding the dentine segment overlaps with the enamel segment in some areas, those overlapping regions will be removed from the enamel segment and added to this new one. Now we can click Apply. Let's check the dentine segment in 3D. It looks pretty good overall, but we still need to remove those unwanted regions. I'll use smoothing again, keep the method on Gaussian, and use the same standard deviation as before. This nicely removes thin areas and connections and separates the dentine from the unwanted areas. Now that they are disconnected, I can go back to Islands, keep selected island, and click on the main dentine in one of the 2D views. Perfect. Now only the main dentine segment remains, and we can consider this segment as completed. Next up is the pulp cavity. I'll hold down Shift and hover over it so it's centered in all the views. Segmenting this part is a bit tricky because the cavity has essentially the same intensity as the surrounding air. They both appear as black. So if I used simple thresholding, the outside air would be selected in addition to the cavity. There are a few ways to handle this, but I have found the SurfaceWrapSolidify extension to be very useful. You can install it directly from the extension manager in 3D Slicer. Before running it, it's important that the dentine is already segmented and selected because the pulp cavity extraction depends on it. Essentially, the pulp cavity is the largest internal cavity within the dentine. So in the SurfaceWrapSolidify, I'll set the region to largest cavity and output to new segment, since I don't want to overwrite the dentine segment. Then I click Apply. Depending on the dataset size and the computer power, this can take a few minutes, and you can follow the progress in the status bar at the bottom. For me, it took about 2 minutes, so I'll put the video on fast forward. Once the process is done, you can see that the pulp cavity is nicely segmented in a new color and saved as a new segment. I will turn off the dentine visibility for a moment and rename this new segment to, let's say, cavity. And if we look at it, you can see how nicely it is segmented without including the surrounding air. Now, for the final step, we are going to calculate the volume of each segment. Any segment you want to measure needs to be visible. So I'll turn them all on using these eye icons. Then, from the module drop-down menu, I go to quantification and select segment statistics. In this module, I just need to make sure the correct segmentation is selected and click Apply. The results table appears down here. Each visible segment shows up in a row, and the corresponding volume is listed next to it. And that's all. Thanks a lot for watching, and if you found this workflow helpful, don't forget to like the video and subscribe to the channel.